Thanks everybody for coming and for making it after lunch. And I really want to thank the organizers again for organizing a wonderful conference and for being a part of the machine learning and AI track. And today I'm going to talk a little bit about something that I like to say, taking don't be evil literally. We're going to talk about ethical machine learning. So we're going to talk about applying ethics within a machine learning context. And we're going to talk about it from a little bit more technical point of view than normal. So on July 17th, 2014, Eric Garner was on a corner nearby his house in Staten Island, New York. And this is a normal corner that he would hang out on his street. He was approached by several police officers. And those police officers confronted him, accusing him of illegally selling cigarettes without a license. The conversation escalated, which eventually ended up with Eric Garner on the ground in a chokehold. Eric Garner had asthma. He had a history of asthma. And these police were on top of him and had him in a chokehold. He was not struggling, and he simply said, "I can't breathe." He said, "I can't breathe, I can't breathe, I can't breathe," until he died of asphyxiation. On the coroner's report, his death was declared a homicide. But no police officer who was there, despite the fact that this was on video, multiple video recordings, no police officer stood trial. No police officer was charged with his death. It was a murder of a black man in America by the police that nobody stood up for. Why, might you ask? Why would Eric Garner have to die over a pack of cigarettes? I myself have sold and bought cigarettes on the street corner in New York. This is not an uncommon experience in New York. You want to bum a cigarette from someone, you ask them for a cigarette, and you pay a quarter. Well, during the Rudy Giuliani era of governorship in New York City, he decided that it would be good to apply something called broken windows policing. And broken windows policing is a criminology theory. And it says, if we target small, tiny crimes, misdemeanors, selling cigarettes, loitering, sitting on the wrong street corner, sleeping on a park bench, if we target these crimes, then it will mean that the big crimes, robbery, homicide, murder, and so forth, that these won't happen. This is a criminology theory, and Rudy Giuliani was like, this sounds great. What we're going to do is we're going to target these small crimes. We're going to target these misdemeanors. And what we have here is a regression line. And this is from the blog 538, which is a statistics blog based in New York. And this is the data for all the New York City police precincts. On the y-axis, we have violations. These are the small crimes, the petty misdemeanors, selling cigarettes, these types of things. And on the x-axis, we have the felonies. These are the serious crimes, murder, and so forth. And what we have here in red is Staten Island Precinct 120, and this is the precinct that Eric Garner died in. That's the precinct that murdered Eric Garner. And what we can see is that it's well above the regression line, right? And what we can see is there's a few other ones highlighted, like the Rockaways, the South Bronx, and Harlem. And if you know anything about the demographics of New York, these are areas that are traditionally poorer and have more representation of Black and Latino populations. And so we can start to see here that maybe these ones where we see much more misdemeanors, much more of these small, tiny crimes versus the large crimes, we can see that maybe policing is representing these communities in a different way. And that's actually the case. So when we look at other broken windows policing, one was called stop and frisk. And it meant that a police officer could stop and frisk you at any point in time. They didn't have to suspect you of a crime. They could just say that, there was something suspicious about you, right? And what they found with stop and frisk is they found it was unconstitutional. It was eventually ruled after many years. And one of the ways that they proved it was unconstitutional was by disparate impact. Disparate impact, they were able to prove that it was unconstitutional because Black and Latino, particularly young men, were massively overrepresented in the amount of people that they stopped and frisked. Massively overrepresented. And so for all of the population, it was 20% likelihood if you were white to be stopped and frisked, and about 80 to 85% likelihood that you were a member of Black or Latino population. And what they're able to show, so this is one algorithmic depiction of disparate impact, and what they're able to show is when the probability distributions vary for an outcome. So here we have an outcome C. C is normally a positive outcome, so we'll say that C is the opportunity to leave the subway without a police officer searching you, right? And we'll say we have a sensitive attribute X. And X equals 0 here is the white population, and we could say X equal 1 is Black or Latino or both Black and Latino together. And what we say is when this ratio is less than or equal to a small number tau, here we usually use 0.8 because it's called the 80% rule, that we say this is disparate impact, this is discrimination. And we can prove it statistically. We can prove it mathematically that if you have 0.2 at the top and 0.8 at the bottom, we receive 0.25, which is well below the small tau that we have for disparate impact. And so, indeed, this was discrimination, and it was discrimination based on race by the police. When they were confronted with this in court, it went all the way to the New York federal court, the police officer said, well, you know, when we look at our data sets, we can show you all of the arrest records. We arrest more Black and Latino men. So, you know, it's proven. They're more Black and Latino male criminals, right? This is their defense in front of the court. Interestingly enough, this same defense was studied with a mathematical paper. And this was a recent paper that was presented at the FAT-ML conference, which I'll talk about a little bit later. And this paper decided to look at predictive policing from a mathematical perspective. And what we see here is a simulation. So they ran hundreds of simulations of the mathematics, and we see a ratio. And the top half is one neighborhood, and the bottom half is another neighborhood. And we see a ratio of all incidents here across the bottom, and then discovered incidents. And as you can see is, if you use the predictive policing statistical model, and you say, every time, first off, I'm gonna start with the data I have, which I know overrepresents certain communities. Because people of all races commit crimes, right? We know this. And I'm gonna overrepresent that, and every time I go to one of these communities and I find a crime, I'm going to count that again against that community. Now you have a limited amount of police force, right? You don't have unlimited police. And so eventually all of your police are concentrated in this one community. And what's underrepresented is crimes anywhere else. So you stop looking for crime anywhere else, and you continue to look for these small misdemeanor crimes like selling a cigarette in the already oppressed communities. What they suggested as a potential correction for this injustice is an improvement policy. And they said, hey, if your statistical model says that you'll find crime the exact same place where you found a crime before, maybe you shouldn't count it. That's the model working as designed, right? But if you find a crime where you have never seen a crime before, or there was an incredibly low probability of crime, this is new information. Even in information theory, we can call this information gain. We should add this to the model, rather than saying we will add more to the model from what we already have observed. And what they found is with their improvement policy that you see a much more even distribution of the police force from their model. So, and that model makes me think, okay, so indeed, the New York City police officer who represented them in court said, yes, this is what our data shows. So if we build a model that operates like a New York City police officer, if we build a model that mimics policing behavior as it currently is, are we creating a valid model? Is this valid? I mean, this is what the data currently is, right? And if we say that Eric Garner shouldn't have been selling cigarettes on the corner and that's why he died, then perhaps our answer is, yeah, it's a valid model. And if we take a step back and we look at it again, we can perhaps ask, if our models mimic the social inequalities, the injustices, the prejudice, the biases, and stereotypes of our world, are we creating a valid model? I mean, I know sexism exists, so if I create a model that will pay women 0.75 of their male peers, and that's what the data shows me, then, you know, it's valid, right? This is a valid model. It mirrors exactly what I see within my data set. It mirrors the social inequalities that I observe every day. And it doesn't take a very far logic step to then get to the question, are social inequalities and prejudice valid? Is it valid to be sexist? Is it valid to be racist? Because if we're automating inequality in our machine learning models, if we're automating prejudice, then that's what we're saying, right? If we're using the same data sets that show all of these inequalities and we say, well, that's just what the data said, then we are signing off on this type of treatment. Then we're signing off on social injustice, and we're doing so in a really tricky automated way where we don't have to be held accountable for the results. However, I hope, because we are here together in this room to talk about ethical machine learning, that our answer is vehemently no. That we say, no, we do not want to automate inequality. We don't want to make it easy for somebody to say, oh yeah, I was just doing what the model told me to do when I murdered Eric Garner in the street. We don't want to recreate these same societal unfair treatment and prejudices and biases and so forth. So we say no to this, and we say instead, there has to be a better way. We actually see perhaps these social inequalities and prejudices as errors, as something that we can help correct, at least within our small circle of influence, right? Unfortunately, we can't fix all of it, but hopefully we can make sure that we don't automate it in our models themselves. So the first thing that we need to do is break the cycle. And by doing that, we need to determine if our data has prejudice. Now, it's likely that our data has some prejudice, and so we need to figure out ways that we can look for it. Well, one of the things that we can use is we can use some simple statistical measures. So we can look at things like correlation and mutual information and conditional information gain. We can look at our basics of how variables interact with one another. And we can say, okay, these variables are influencing or highly correlated with these sensitive attributes. So when we look at a sensitive attribute like gender or race or age, we can then say, okay, this data set shows a class imbalance in terms of this particular subpopulation. And one library that I like for this is called FairTest, and it came out of academia, so I will say it's academic code. Love when academics publish their code, but it is academic code, so. But they're using basic correlations and subpopulation studies. So they're sampling subpopulations across a series of sensitive attributes. And so here, the sensitive attribute for this particular subpopulation is gender. And we can see this is the UCI adult machine learning data set, which you might have seen before, that tries to say, is somebody earning above or below 50,000 per year? And what we see here is that it found a subpopulation where it had more normalized mutual information than many of the other subpopulations. And we can see that women attaining an education of greater than 11.5 years, that they're dramatically underrepresented compared to their male peers. And even when they have attained that education, they do not represent the same amount of greater income. And so if we're going to use this to build a model, and let's say we just naively remove gender, we unfortunately have this other underlying mutual information where if we find that education has a strong significance, that this is going to affect our model and it's going to unfortunately still treat women unfairly. So what perhaps can we do? There's numerous things that we could do in terms of data preparation. We could build separate models for the different subpopulations. We could also make sure that we're testing for error rates in our subpopulations and comparing drastically different error rates on our finished model. But sometimes the best choice is to build a better data set. So sometimes we have to encode our data, right? It's image data. And here I'm going to talk about facial recognition a little bit. And there's a researcher at MIT, Joy Buolamwini, and she was doing some work within her research group, and she found that a lot of the facial recognition services didn't work for her. And when they did work for her, if they were classified to, let's say, gauge or predict gender, they often misclassified her as a man. And she said, I don't know what's going on with this, but I'm going to take a look. So she proceeded to try and train her own facial recognition model. And when she had a look around for what data sets were available, she found that they were predominantly white and predominantly male. And so she said, well, this is starting to make a little bit more sense. And what she proceeded to do was say, you know what, I need a different data set. I need a benchmark that can properly represent multiple skin tones. And she put together what's called the Pilot Parliamentary Benchmark. And this has members of parliament from many different countries around the world. Now, this means that there's not a variety of head poses and so forth. It means it's not the perfect data set for all facial recognition problems. But she was interested in looking at this gender classification. So once she had put together this pilot parliamentary benchmark, she tested it against Face++, IBM, and Microsoft, which all offer APIs to predict gender based on your face. And what she found was the error differential between a darker-skinned woman of color and a white man was a 30-point difference. It's pretty massive, right? And she reported the results to the different APIs, and the really cool thing that we can take away from this is IBM wrote her back the next day. They had her come visit. They had her change they had her use her data set along with other data sets that they collected to update their training data. And then they released a new API that was trained on this new data set. And I encourage you to read her other work. It's at gendershades.org, and she has also started something called the Algorithmic Justice League. And so she has decided that building a better data set is sometimes the answer. So another type of data that we often deal with is language, and this is difficult because linguistic data, we have to figure out how to train, and you have to have been under a rock to figure out that word vectors are the new way, right? So it's great because man plus king minus woman is queen, so we fixed NLP, we solved the NLP problem, everybody can just go home. Now it's great, language is solved. But not really, right? And those of us that work with NLP, we know better than that. But the problem here is that what we've found is we train word vectors without any labels, and we just feed it a bunch of text. And what was proven when word vectors started gaining popularity is that there's harmful associations encoded into language that then these word vectors represent within their multidimensional space. And what was found, it was a great article, I recommend reading it, within Science by Aylin Kaliskin and a few other researchers, was that if you take a gendered language like English or Portuguese or French, Spanish, so forth, and you translate it into Turkish, a gender-neutral language, And let's say the phrase was, she is a doctor, he is a nurse. When you translated it back, you got, he is a doctor and she is a nurse. So we found these harmful biases, and if you looked more into depth into them, you found even more harmful biases, a lot around different sounding names, nationalities, and so forth. And I did a little bit of research around these, and when I was preparing for this talk, I was curious about the intersectionalism of Brazilian women, and if I could find intersectional feminist issues where, of course, sexism and racism combine to oppress people. And so I took a look at the Google News vectors, and these are the Google News 300-dimensional negative sampled trained word vectors directly from the source. And if I said Brazilian plus woman, this is what I got. I have no idea why Rihanna's there. The Giuseppina Pascalino, she's a murdered Italian artist who was murdered and raped in Turkey. I don't know why she's there. Latina teenage girl and Michael Jackson. And I was curious to look a little bit more, and I want to warn you that I'm about to probably offend you, and I'm sorry. These are not my word vectors, I didn't train them. I'm not also trying to blame Google. Word vectors are hard, but these are the Google News word vectors. And I found teenage girl to be interesting. So I said, okay, well, let's try Brazilian girl. What could go wrong, right? Brazilian girl is fairly innocuous. And this is what I found. It actually gets worse. So if you continue to look at the next 20 vectors, you get worse than that. And first and foremost, I think Google needs to build a better news classifier, because I'm pretty sure that shaved pussy is not in the news. Just gonna go out there on a limb and say, probably not. But we see that we have these issues, right? And if you're building a chatbot based on word vectors, and shaved pussy is 6 steps away from Brazilian girl, you're probably gonna run into some issues, right? I mean, you don't necessarily want your bot to be like, yeah, sure, no problem. Or if you're using it to summarize text, or if you're using it to inform your text in some way, it's problematic when we have these types of phrases and that they're overrepresented when we look at intersectional communities in terms of language. So we can do better than, I hope we can do better than this. If not, we should just all quit, turn off all the computers, and go home. So one of the ways that we can perhaps do better is called hard debiasing. And this came out in a paper a few years ago where the researchers were able to look at the biases within the word vectors and say, okay, this is a subspace. We have a multiple dimension subspace, and we can potentially project away the issues. And that's exactly what they were able to prove that they did. Using simple dot products of vectors, they were able to normalize and project away the gender subspace. But this meant, the paper was called Computer Programming is to Man as Woman is to Homemaker. So that's always like inspiring as a woman in tech. I'm like, yeah, I should just go home, you know? So what they were able to do is they took a bunch of different professions or words that they found had gender connotations, and they projected away the subspace by a simple vector transformation for these words. But what this means, as I'm sure you're thinking, is, Katharine, then I have to label every single gender-neutral word in my data set, and yes, that's what it means. And that is really perhaps not scalable and problematic. So one of my challenges is, perhaps if you work within this space, we need to find a better way. We need to find a more automated way. We at least need lists of words which we should look at for bias. And when I was thinking about this problem in terms of Portuguese and Brazilian Portuguese, I did some research on the many different ways that people can identify their race and ethnicity, and I found that in Brazil, there's like over 50 or 60 words. And so if you're looking around to debias these words for racial problems, right, racial inequalities, and you have a language like Brazilian Portuguese that has many different ways to express oneself, you're gonna have to search quite a lot of subspace. And this is problematic, and we need to find better ways, but we can correct for it. And so this means we can fix the word vectors, we can use better training data, and we can project away issues that we see. So we've supposedly, like hopefully at this point in time, we've found the biases within our data set, we've corrected for them, we've collected perhaps new data, we've debiased our word vectors, and now it's time to actually train and evaluate our models. And what we need to do is we need to use all of the same indicators we normally would, plus a bunch of indicators for fairness. And the first thing that we actually have to do is define fair. And unfortunately, we would think, oh, fairness is equal treatment of people, not based on who they are or who they know, is equal treatment, right? But unfortunately, within algorithmic definitions, we have found over 21 definitions of fairness. And so Professor Arvind Narayanan, who has worked a lot in fair machine learning, presented recently at the last NIPS conference on these 21 different definitions, and I highly recommend looking at his talk and article. But another research group, this is at the University of Utah and Haverford University, they have started a blog called Algorithmic Fairness. And it's really neat. And what they did is they first did this benchmark study, and it was the first comparative benchmark study of different definitions of fairness alongside accuracy on the same data sets. And they released all their code on GitHub and so forth, so you can have a look at it. And what we have here is a correlation approximation with different data sets. And we can see that different definitions of fairness and accuracy, that they have different correlations. But we can also see that there's a bit of pockets, right? That we have some that are strongly negative correlated with the others, but correlated with one another. And this tells us something positive that we can learn, which is when you optimize for one type of fairness, there's a chance you're optimizing for a few other types that are related. And I recommend, again, looking at their benchmark, but what they were also able to prove is it's not always the case that you have a fairness and accuracy trade-off. That they found this to be most the case when you had to do a particular type of preparation and when you had severe class imbalance. So these are things that we can then focus on in terms of not only the data sets that we collect, but in terms of how we optimize our algorithms and our models. So hopefully we've found a definition of fair or a few definitions of fair that work within our problem space. And there's many to choose from, but we've decided on one or two. Well, then we need to actually chart them alongside our normal indicators. And here was an article by a consulting group called Go Data Driven, and they work on a lot of machine learning and deep learning. And what they decided to do is they said, what about if we use a GAN? How many people here have used generative adversarial networks? Okay. And they decided to use a GAN, and I'll describe briefly what a GAN is. You have two neural networks. One is trained on the problem set. So here it's the adult data set, and it's determining again if somebody earns more or less than 50,000. And then you train another neural network, which is a discriminator. And this neural network tries to guess based on the predictions from the other network. And their discriminator, they decided to train with an eye towards disparate impact. And they said, I want the discriminator to guess, based on the output of the previous neural network, I want it to guess whether it's a woman or a man, and I want it to guess the race of the person, black versus white. And what they were able to do, and essentially the discriminator then adds to the loss, which backpropagates, and via the gradient, we can then update the other neural network and make it better. In this case, making the first neural network more fair. And what they found is, as they were training, and they continued, that after about 150 training epochs, they were able to reach a disparate impact proportions. So they were able to say that they followed the 80% rule. They did lose some accuracy. They lost about 10 points of accuracy. And this is commonly the case when you're using disparate impact measures. Now there's other measures. For example, I highly recommend taking a look at the research around something called equal opportunity or equal odds, which instead looks at the ratio of true positive or false negative for particular populations. And that one has been shown that it doesn't necessarily decrease accuracy. But we need to, the point of showing this is that we need to make it really visible. Until we make fairness an evaluation criteria that's really visible within our training, then we have no idea how our model will behave until it's too late. We've already validated it, we've already tested it, we've already signed off on it, and now it's treating people unfairly. So we need to have this as part of our training. And I think it was a really neat concept to use again to do so. And when we're in a linguistic space, there's another research paper that recently came out from Google that gave us a new measurement which they call the bias score. And they used a particular embedding space where you can have multiple length embeddings. And what they did is they said, okay, we're going to build a chatbot. I'm going to have the chatbot be asked a few questions about gender-neutral professions. So here is the captain here today? Then we're going to build some response vectors, and we're going to take the cosine similarity of those vectors with the question, and therefore determine if we have gender biases within our responses. Here we see that we have a 0.1 bias score that is biased towards the masculine direction. And what they then said is then you could use debiasing or other types of training to essentially correct for these differences in the cosine similarities. Again, with NLP, we find a solution that is incredibly person and labor intensive. And I think, unfortunately, that we're going to have to experiment within this space to find ways to make it better. But it does show that we have some new measurements, perhaps something that we can optimize for when we're first building and creating our response vectors. We can also look at an interdisciplinary approach and perhaps start using gender-neutral pronouns or other types of signifiers where we kind of strip away the gender preference within our vectors. And finally, when we're thinking about machine learning and making it more fair, we should also be talking about interpretability. And if we interpret and introspect our models and we find the errors, the reason for these biases, then we can hopefully figure out better ways to correct for them. And this is from one of my favorite papers on interpretability called Show, Attend, Tell, and it was about neural image captioning. So it was a CNN to classify the image, and then they used an RNN to generate tests, a recursive neural network. And one of the nice properties of a recursive neural network is you have not only the long-term but the short-term information available, and you can therefore project what they call attention. So we can use the attention of the neural network at a different point in time to observe the errors. So here on the left, we can see the image is two giraffes standing in the forest, and instead the network says a large white bird standing in the forest. We can see where it's focused when it's focused on the word bird, and we could say, oh, perhaps we need to show more different pictures of giraffes in groups. Perhaps we need to normalize or correct our images in some way, but it gives us an idea as the machine learning specialist in the room to figure out ways to fix the error. And I would say if we use things like this interpretation, as well as many of the other work in interpretation, such as LIME and many other algorithms that are coming out, we can start to look and correct for the errors that are the prejudice and the biases within our models. Finally, I hope that we've trained our model, we've released it, it's the best that we can do, at least right now. We're going to continue to work on it. But the more transparent we are, both with our end users, other stakeholders, and our peers, the more we can move the conversation forward. So the first and foremost is that there shouldn't only ever be one talk about fairness, transparency, or accountability in machine learning at a machine learning only conference. Now, I can highly recommend looking at the Fairness, Accountability, and Transparency in Machine Learning conference itself. And they have published papers now for 6 years, and lots of different panels and conversations and videos and so forth. So I encourage you to take a look at them. You can also look at Joy Bulamwini's work around the Algorithmic Justice League, or AI Now, where they recently did a fairness report on the state of machine learning. But really, it's also about conversing with your peers and saying, moving beyond the why. Right now, a lot of the conversation is, why should I care about ethics? I'm just doing my job. I'm just driving the train, right? Why should I care? And I think that we need to move beyond the why into the how. We need to start having the difficult conversations of how we can best optimize to solve these problems and to create better data sets, create more fair and representative data and models overall. So if everybody in here goes and has a conversation with a peer or a friend or stakeholder, then we can start to have the network effect, right? Secondly, if we want to build ethical machine learning, we also need to build ethical products. And this means it's a lot easier to make a business argument to the boss that you need to build an ethical model if the boss believes in ethics, right? And so Indie is a really neat company, and they have published a manifesto on ethical design. And in their ethical design manifesto, they have this chart where we're optimizing for respect. And the first layer of respect that we optimize is human rights. We create something that's decentralized, we create something secure, we create something open to different persons that's easily integratable into their life, that solves their problems. Once we've done that, we move up the pyramid to human effort, where we're working on respecting human effort. And in this, we're respecting that our chatbot doesn't treat women and men differently, and that our facial recognition doesn't treat darker or lighter skins differently. Right? So we're respecting that human effort. We're making something reliable and functional for everyone, for all different persons who want to use our application. And finally, we're respecting human experience. And this means we're creating something truly delightful, truly amazing. And this is kind of where we all want to be, right? We want to build something that we're proud of. If we're going to spend all of this time studying and working and becoming experts, we definitely want to make sure that we can be proud of our work and our end product. And I would say ethical machine learning fits in well with this. Finally, I would say that ethical machine learning is taking a logical, even one could argue a scientific stance against oppression. That by incorporating ethics and not ignoring them in our models, that we are taking the only logical stance when looking at something like unfairness in the world. And so what I hope that you can take away today is first and foremost that doing absolutely nothing is doing something. That apathy when approaching these problems means that you're signing off and validating on the unfairness in the world. And if you simply say, I didn't know, then guess what? You did know. You're the one looking at the data. You didn't look for it. You're the expert. You're the person in the room that understands probability theory and distributions, and if you didn't look for it, if you didn't account for it, and you didn't think about it, then that's on you. And even if nobody else will blame you, I will blame you. So, I know, I don't live in Brazil, so I can't come find you, but you know. So you can't do nothing. If you're doing nothing, then you're making a statement. The next takeaway, I hope, is that we definitely need better data. And if you've been working on machine learning for a while or machine learning in production, you already know this. Our data is not that great, especially the open data sets. And we need a lot more data, and we need it more labeled, and we need representative data, and we need diverse data. And this is something that we're going to have to work on as a community. This is not just going to magically come out. And even if great companies in terms of open sourcing some of their work, like Google. Even if they give us word vectors, it doesn't necessarily mean that they were fixed, right? So we need better data, we need diverse and representative data, we need to put together data sets like the Algorithmic Justice League is working on, and we need to, whenever possible, open source it so that we can have better data sets and better models for everyone, not just for the few that work for a large corporation where they can get everyone's data. And we also need to stop using data sets that are non-representative. So if you find that you have a data set that's non-representative and you're on a timeline, I need you to go to whoever set that timeline and say, hey, guess what? We need 2 months to label data and collect data, and that's that. Finally, we also need built-in ethics-driven evaluation criteria. So within our same evaluation criteria that we use today, when we're looking at our precision or our recall or our area under curve and so forth, we also need to look at our fairness metrics. And this should just be normal. This should be the same way that we're charting accuracy, we're charting disparate impact, or we're charting equal opportunity or equal odds. And we're taking a look at how we're treating different subpopulations of our overall sample. And this evaluation criteria needs to be held to the same respect as our normal precision or accuracy and so forth. And if you work on an open source library like scikit-learn or Spark ML and so forth, it would be really awesome if this was just built in, because the easier we make it for people, the easier it is to incorporate this into our normal workflow. It shouldn't have to be hard to build ethical models. We should make it easy. Finally, I hope that you take away that you can contribute. That indeed it is on us as a community of data scientists, data engineers, machine learning practitioners, experts, researchers, and so forth. Nobody else is going to do it. When I go to these conferences and I look around and I meet brilliant, amazing people working on great things, I really think to myself that we indeed are the 1% in this situation. We understand, we have studied, we have worked to get here. And if anybody is going to change the path of our field, it is us. And I think, like physicists took a stand after the atomic bomb, we need to take a stand and look around and say, you know what, I do not want my legacy to be automating racism. I don't want that to be what I contributed to the world. And to do so, we really need to stand up and get involved, and we need to do so sooner rather than later. And so I challenge us as a community to volunteer to get involved, to open source your data sets, to talk about these issues, and let's work on solving them and finding ways to make the world better with our work and our expertise, not make it worse. So I want to say thank you so much for joining me today. And I will take questions now, but also I can take questions later. If you want to reach out on Twitter, I'm KJam, and here's my email. Thank you so much for joining me. Yeah, sure.
Perguntas, pessoal.
Hello, congratulations for your presentation.
Thanks.
Do you have any idea how big companies are working the subject of ethics and how to remove the prejudice from their data?
Yeah, so the paper that I referenced from Google came out with some new word embeddings. I haven't had time to fully explore them, but they're looking much better so far. And so I think that they've held that accountable. There's also been some, IBM of course responded very quickly regarding the gender shades, and so I'm hoping they're also thinking of diversifying their other data sets. For better or worse though, I think that the onus is really also on the community to kind of pressure, and when we find these things, to bring light to them. I feel like we can even treat it like a security community and give them, 0-day warnings and so forth, that we really need to say, hey, guess what, I found an issue. And I think also one thing I've been thinking about a lot is within our own applications, how do we let users report a fairness bug or something like this? Like, really need to figure out ways, how can we treat unequal treatment like a bug, right? Which is what it is, or an error that we can hopefully, at least within our small sphere of influence, correct for. So I think making this easier to do bug report, hey, guess what? You translated me into a man, or this or that, or whatever other things that we find that we can figure out better ways to report it, and then also to report it up to larger companies. But I can only hope that, negative press is motivating in and of itself. Yeah, I agree.
Hi, thanks for your talk. It was pretty awesome. And I have one question. Has there been any active research towards better investigating automated right to an explanation, such that how do I have an automatic response on why I was classified, or why was I labeled in such a label?
Yeah, so this is interesting because we'll have to, the only thing really that is holding us legally accountable to something like this perhaps is if we start treating explanations as a feature, which I feel like we should say like, hey, explanations are a great feature, and it gives feedback to the user, and they can therefore say, hey, you made an error because I don't look like that, or that's not my gender, or that's not whoever I am, right? But one interesting development recently, of course, is GDPR, which is the General Data Protection Regulation, which will go into effect on May 25th within the EU. And what this allows for, there's a particular article, and what it allows for is what some people are calling a right to an explanation. Now, legal scholars are debating whether this actually exists, but what it does allow for, the language essentially says that people are allowed to inquire about automated decision-making processes, particularly those that affect them negatively. So we can think about this like bank loans, education, job applications, these types of things. So what I'm hoping is that GDPR puts a little bit of pressure on companies to say, hey, oh, guess what, your credit was declined because you live in a zip code that we don't support, and we can start to then uncover some of these unfair treatments by exposing when the explanation is clearly racially motivated, or gender motivated, age motivated, language motivated, nationality motivated. So this is my hope, at least.
Last question? No? Katharine, so thanks.
Thank you so much,
Very
Emerson.
much.
Thanks.